The Phoenix mission landed on the extreme edge of the North Polar region in Mars and imaged a whole bunch of hummocky areas where you have these polygon-shaped hummocks which look exactly like the hummocky regions here on Earth that occur in the tundra during the seasonal freezing and thawing. So very similar features on Mars as there are here on Earth. Europa, the first time that we saw this exotic and bizarre terrain on the surface of Europa was when the Voyagers went by in the late 80s, in the late 70s and the late 80s. And what was very interesting about this surface is that it's very smooth. There's very few planes, it's very smooth, almost zero craters. So that shows right there that this must be a very young surface, it must be constantly renewed, so there must be a lot of subsurface hydrology going on to continuously renew the surface of the planet. The Thera and Thrace Macula are two areas that are very similar, but they have some distinct differences. The Thera macula is a region where there must be some kind of melting taking place below the surface because it is sunken down below the mean level of the surface. The Thrace is elevated above the mean surface of the planet. So there has to be some kind of slush, water, something warm rising underneath this area to raise this above the level of the surface. And the Conamara Chaos are large areas where it's very similar to places like the Arctic ice sheet here on Earth, where during the seasonal changes with the melting of the ice sheet, big blocks of ice grind and crunch, and then it refreezes and it leaves these big blocks all tilted and rotated and half submerged. The same thing is going on here. These big blocks of ice have been partially melted, moved around, tilted, rotated, and then reform. And there are also these really bizarre, very straight line ridges on the surface of Europa. And these are areas that, due to the tidal forces and from Jupiter and the other moons of Jupiter, are inducing a lot of stress on the surface of Europa and causing big parts of the surface to either pull apart, push together, or slip along each other, forming these ridges of materials. And some of the ridges, as you see, form these what are known as cycloids, these kind of an arc, and then they'll change direction and arc again for a while, change direction and arc again for a while. And these are basically, again, you have the tidal stresses and forces being induced upon Europa, pulling the surface in all different directions, but Europa is not tidally locked. It's not in synchronous rotation with Jupiter, so it rotates as it orbits. So when you add that motion to the other motions, it causes diurnal stress fields to change the direction of the surface where it's bumping and grinding and slipping and sliding along each other, producing those cycloids. It's not known if these are actually repeat each other or if they end up being just disconnected as it goes along and it never comes back to the same spot. And plains, basically the lack of plains is the only thing of interest here. No plains, no craters, constantly being renewed surface, very active surface. It has been determined that about 70% of the mass of Europa is in the form of water. So there's a lot of interest in Europa, and there are future missions going to Europa to study the subsurface hydrology. Enceladus is one of the moons of Saturn, and here again we have a lot of different terrain on the surface. We have areas that are totally uncratered, we have areas that are heavily cratered, there are long fissures, and there is this wrinkly corrugated terrain over here, And down here, these are referred to as the tiger stripes, kind of parallel ridges. And there have been, now, the Voyagers went past here a long time ago. Also, the first time that we had any intimation of what was going on with the moons of Saturn. 98 plumes have been detected. There's been one other mission that we'll get to, also to Saturn. 98 geysers have been detected in the southern part, near the Tiger Stripe area, in the southern part of this moon. And those geysers are ejecting materials, ices and organics above the surface. Again, they form plumes that settle on the surface. And this area of tiger stripes here is very similar to what's going on the surface of Europa. It is places where the surface is being stressed enough that sections are pushing together, being pulled apart, pushed together, slipping along. Again, the tidal forces produced by Saturn and all the other moons of Saturn on the surface of Enceladus are causing this flexing to happen. And when this happens, the surface, especially where it's being pulled apart, that allows the geysers of debris and icy and organic materials to be ejected above the surface of the moon. This is an orbital position map, which maps the fault parallel and the vertical displacement caused by the movement along the tiger stripes along the surface. Always make sure that any time that you find a graphic or a chart or an illustration or a diagram that is related to water and how it is related to surface features, make sure that you use that to study and prepare for this particular event. Iapetus is the third largest moon of Saturn. It is famous for its very dark regions and its very light regions. It has this ridge here. It's very heavily cratered, and it is thought that the dust and the icy materials from the other moons kind of settle along the equatorial region of poor little Iapetus, and then when the radiation reaches the equatorial region, it sublimates the frozen icy material, which then settles in the polar regions. So the equatorial region keeps getting darker and darker and darker, and the polar regions keep getting brighter and brighter and brighter. So the area of focus of study on this particular moon is the transitional area between the light areas and the dark areas, because this gives the best idea of the seasonal changes ongoing on this particular moon. As far as that ridge goes, it completely encircles the entire planet. And there are two theories involved with this. Either Iapetus at one time was rotating much faster than it is now, sort of like the Earth, rotates fast enough, and there's enough liquid that the equatorial diameter is longer than the polar diameter, so it's sort of like an oblate spheroid. It's not a total circle. And the same thing happened here, and as its rotation got slower and slower and slower, that material just formed this ridge around the equator of the planet. Or maybe it was a ring of material, similar to the ring of material around Saturn, that simply collapsed onto the surface of the moon and formed that ridge called the wall. Of course, Titan is the very famous moon of Saturn, which has a very thick hydrocarbon atmosphere.